Pythagorean theorem, level 2. Find the length of the third side if necessary, write in simplest radical form. Again, as soon as you see simplest radical form, be aware that the final answer, you're going to break it down to its primes and pull out pairs. Okay, so let's draw the triangle and label the side lengths. So draw something that looks relatively close to what you have here. So it kind of almost looks like the same problem. But the difference here is, let's see, this side is 4. Actually, I can do a better 4 than that. So we have 4 square root 3. I don't know this side. There's my right angle. But I do know this side, so we know the hypotenuse here. So let's use the color coding. Again, the sides that actually touch the square are the legs. So there's an A or a B, and this is an A or a B, whichever. And then the side that is across from the right angle, that's our hypotenuse. Remember that the hypotenuse is always the longest side. And again, we'll draw our arrow just to make sure. There's our hypotenuse. Switching over to red, I'm going to call this A. This will be B, and obviously this is going to be C. Now that I have the triangle drawn, I'm going to put the numbers in the given variable into the Pythagorean theorem. So first, the formula, A squared plus B squared is equal to C squared. 4 root 3 is going to go in for A, so I've got 4 square root 3. And all of that's inside parentheses, and then we'll square it. Plus B squared, again, we don't know what our B, this leg, is right here, but our C is actually 8, and then squared. So let's do the easy stuff first. 8 squared is really 8 times 8, so that's going to simplify to 64. This will remain B squared. And then if you remember from the last one, we're going to do 4 and we'll square it, and then 4 squared is 4 times 4, so that's going to give us 16. And then when we have a root 3, the square root of 3 squared, the square, that little 2, and the square root symbol will cancel each other out. So really, this is going to simplify to 16 times 3. Okay, plus B squared equals 64. So now we're going to have to multiply this. 16 times 3 is 48. So I have 48 plus B squared is equal to 64. And then to isolate our B squared, I will subtract 48 on both sides of the equation. These are called the properties of equality. Whatever you do to one side, you do to the other. So now we have B squared is equal to 64 minus 48, which is 16. And then finally, we'll get rid of the square, that little 2, by square rooting both sides. Again, properties of equality. So this will simplify to B is equal to, but remember, we have to try and break down this number because it said simplest radical form. So I'm going to break down 16, and I'm going to go ahead and do 2 and 8. 2 is prime. Then I'm going to break down 8 as 2 and 4. And then I'm going to break down 4 as 2 and 2. So it looks like we have a whole lot of 2's. Okay, so I'm going to take all those prime numbers. I'm going to put them back underneath the radical. So I should have 2 times 2 times 2 times 2, because there's 4 2's there. I'm going to pull out this first pair of 2's and put 1 on the outside. I'll pair up the second pair of 2's and I'll put another 2 on the outside. So just to clarify, everything simplifies under the radical, and then on the outside I have 2 times 2, and that will simplify to 4, which makes sense because the square root of 16 is just 4. So I'm going to come over here and say that B is equal to 4. Feeling pretty confident, so I'm going to box that one. Now we're going to go back to Delta Math and we're going to check it out. Again, green check mark is good. Red X isn't bad, but if you get a red X, again, I want to caution you, slow down and find out why you got it wrong. Let's see how we did. We got it. Hopefully you found this helpful.